Hey folks, our next unit deals with gases. We've talked about solids, we've talked about liquids and the forces that allow them to stick together. Now let's talk about gases. So the question I pose is, how is it that we're able to smell perfume when somebody walks by, and it lingers for a while? Or you walk into a room and there's a smell of some sort, food or something like that. How is it that all that can be explained? Well, it all can be explained with what's called kinetic theory. And kinetic theory is an idea that uses kinetic energy as a base for how it is that energy gets transferred from point A to point B, and then that controls the behavior of how gas particles behave. So kinetic energy, as you recall, is the energy that an object has because of the fact that it's in motion. So what kinetic theory does is makes two really important assumptions. Number one, it assumes that the tiny atoms that make up the matter that are moving around as a gas are in constant motion. They never ever stop. They're constantly moving. There's no reason for it to stop. And when relating to gases in particular, we're going to assume that they behave perfectly. And what chemists use in terms of in a new term instead of perfectly is we use ideally. So we're going to say that a gas acts as an ideal gas. So how is it that we think of a gas as an ideal gas? What are the sort of the characteristics of an ideal gas? And there are these 7 assumptions that I want you to know, understand, not memorize, but just understand how they work. And that's going to sort of be the basis for all the stuff that we talk about. The first thing that we're going to assume is that gas particles are hard little teeny spheres that are moving around. Now, is that true? Well, remember, atoms are squishy spheres, right, with orbitals. But thinking of them as hard little spheres makes our life easier. Next, we're going to assume that since gas particles are made of atoms and atoms are really small, that the volume that a gas takes up itself, not that it's moving around in, but the gas particle's volume itself is really small. That's like saying what's the amount of volume that you take up in a school building? Your body itself. It's so small compared to the school building that it's insignificant. So we can neglect it. Relative to the size of the individual gas particles, they're really far apart from each other. So when a gas particle, all the air in the room, the individual particles of oxygen are so far apart from each other compared to their size. And that the atoms that make up a gas don't attract or repel each other. There's no reason for them to attract or repel because they're flying by so quick. And if a gas is allowed to escape from a container, then it's going to escape and it's going to move on and expand and expand and expand throughout. And eventually, if you wait long enough, it'll hit the end of the universe. Gas particles, when they move quickly in straight lines, randomly. They don't go anywhere in particular. They're not twisting or spinning around. They're just kind of going in straight lines in constant motion. And for any reason, if they change the direction that they're going, they're changing their direction because they're hitting something. And when they hit something, they bounce off. And all the energy that goes into the collision comes right back out. So imagine a ball that you take and you throw on the ground. Boom, you hit the ground and it bounces up and it bounces down, up, down, indefinitely forever into the end of time because it constantly has the energy that it had in the collision transferred right back to them. So these 7 assumptions we will use and consider whenever we're thinking about a gas if it is ideal. And these assumptions help us to think of a gas so that it's simple to think about. Because if you start thinking about it not being a perfect sphere or that the volume isn't negligible or all those kinds of things, it makes life a little bit more complicated to understand. And those are topics that we talk about in the next course, which is AP Chemistry. So we're not going to discuss most of those things in this course.